Hi students, welcome to the Aspn classes. So this is the second video of the continuity and differentiability chapter. In the last video already we discussed what is continuity, what is discontinuity. Today I am going to discuss that continuity and differentiability. First exercise 5.1, all the example I am going to solve here. Okay, so let us start. Okay, observe your first example is show that the function f of x is equals to 5x minus 3 is continuous at x is equals to 0, at x is equals to minus 3, x is equals to 5. F of x is equals to 5x minus 3. Right? So in this case, first you check out x is equals to 0. You have to prove that this result is a continuous. Already they are given here. The given function is a continuous at all of these 3 points. First point you take it x is equals to 0. Okay. So when you say that the function is continuous, that limit answer and function answer, both answers are exist and value also same, it then only say that the function is continuous. Okay. So now you have to take out the first limit answer. Limit of x tends to 0, f of x is equals to limit of x tends to 0. What is the f of x they are given here? 5x minus 3. Now you have to fill up this 0. What is the answer? 5 into 0 minus 3. So 5 into 0 is 0 minus 3. It means you get the answer is minus 3. Okay. So now this is the result is limit answer. Limit of x tends to 0. Similarly, you may also find out the function answer. F of 0 is equals to 5 into x in the place you have to take out the 0 minus 3. Again 5 into 0 is 0, 0 minus 3, it means this answer also getting minus 3 only. Okay. Limit answer also 3 minus 3 and function answer also minus 3, it means both are the same answer. It means limit of x tends to 0, f of x is equals to f of 0. These two answers are exist and equal, therefore the given function is a continuous at x is equals to 0. The given function is continuous at x is equals to 0. So one point is clear, that is continuous at x is equals to 0. Again one more point is given, that is x is equals to minus 3. Okay, let us check it. This result also you have to prove that it is also continuous. Okay, so what is the first, you check out the limit answer. Limit of x tends to minus 3 f of x. Then limit of x tends to minus 3. What is f of x here? 5x minus 3. Now here you fill up x in the place minus 3. Then what is the answer? Check out f of minus 3 minus 3. 5 into 3 means minus 15 minus 3. Again this result you get minus 18. Correct? Same case in this limit answer you get here, and function answer also same only. F of minus 3 is equals to, what is the result of 5 into minus 3 of minus 3. Again this result also getting minus 18. Okay, so function answer and limit answer both are getting same. So both are getting same, it means the conclusion is what? Limit of x tends to minus 3 f of x is equals to f of minus 3. Correct? So both answers are same, therefore the given function is continuous at x is equals to minus 3. That is clear? Okay, again one more point is there, that is x is equals to 5. You will also check out this result also. Again I am going to take it here. Limit of x tends to 5 f of x, and limit of x tends to 5. What is f of x? 5x. Okay, 5x minus 3 here. 5 into 5 is 25, or 25 minus 3, it means you get the answer is 22. And function answer also getting same result here. 5 into 5 minus 3, 25 minus 3, it means 22. Therefore limit of x tends to 5 f of x is equals to f of 3, sorry, f of 5. Okay, these two answers are also same, therefore this function is also continuous at x is equals to 5. Last conclusion you write here, the given function is continuous at x is equals to 0, at x is equals to minus 3, and x is equals to 5. Okay, second example observe here. Examine the continuity of the function f of x is equals to 2x square minus 1 at x is equals to 3. So what is the function they are given here? F of x is equals to 2x square minus 1 at x is equals to 3. So these are the given pointer. Now you have to examine that question is continuous or not. So the given of x is equals to 2x square minus 1. Now check out this limit answer. So first limit of x tends to 3 f of x is equals to limit of x tends to 3. What is the function here? The given 2x square minus 1. So 2x square, it means 3 square minus 1. 3 square answer is 9. 9 into 2 is 18 minus 1. It means 17 you get. So this is your limit answer. Correct. So then limit you get it means then you check out the function. F of x is equals to, that result also same, 2x square minus 1. Then f of 3 is equals to 3 square, again 9 and 9 into 2 is 18 minus 1. It means you get the answers are 17. So f of 3 answer and the limit answer both are same. Therefore the conclusion, limit of x tends to 3, f of x is equals to f of 3. These two answers are same. Therefore the given function is a continuous at x is equals to 3. Third one observe. Examine the following function for continuity. Okay, first function is f of x is equals to x minus 5. Okay, see, observe, compared to last two example they given here at the point, but here just to check out, examine whether the given function is continuous. It means they are not given any point. It means you understand you have to check out all the real number, every real number you have to check out is this continuous or not. It means generally you have to prove this result. Generally it means you have to remember x is equals to c, you have to take out. They are not given any point, it means you take it x is equals to c or k also you can denote here. C nothing but is a constant number. Okay, so now you have to check out same procedure. It is also simple. First you check out the limit x tends to c, f of x, and then limit of x tends to c. What is f of x here? X minus 5. And then when you are applying the limit, it means what is the result? C minus 5. Now you get the limit answer is c minus 5. And similarly in function also you have to check out f of x is equals to x minus 5. Then f of c is equals to c minus 5. Then the function answer and the limit answer both are getting same. So limit of x tends to c, f of x to f of c. Therefore the given function is continuous at every point, or the given function is continuous at c also. You can write it here, c nothing but all the real numbers. So first example is clear. Okay, here again second example observe here. In this case also observe here 1 divided by x minus 5 is there. It is a rational function, correct? The given function is a rational function, therefore the function is continuous. May also take the proof, it means you may also write it here again already x is equals to c, you have to take out, then you have to apply the limit of x tends to c, f of x, and then the limit of x tends to c. What is the result? 1 divided by x minus 5. Then applying this result, it means 1 divided by c minus 5. Same result is also getting here, f of c answer. Okay, when you are applying here c, it means again you get the same answer. It means the limit of x tends to c, f of x is equals to f of c. So now you get this result. It means the given function is continuous at every real number, because they are not given at the point, no. So you are checking all the points. So therefore the given function is continuous at every real number also you can consider. Okay, so next example observe here, third one. F of x is equals to x square minus 25, x plus 5. Again here x is not equals to minus 5. Here minus 5 you fill up, it means again denominator will be getting 0. That's why except minus 5 consider all the real number, check out it is continuous or not. Okay, so now we have to check out here again the directly also you can observe, again this is a p by q form only. This is also continuous function and this is also continuous function. It means rational function is a continuous also, you can write it, but you may also take the proofs. So it means you take it here x is equals to c only, a limit of x tends to c, f of x is equals to limit of x tends to c. What is f of x here? X square minus 25 divided by x plus 5, correct? Okay, so here observe this. In this case observe it here. I think in first year already solved this type of example. Whenever you get this type result, it means you may also take out this simplification, limit of x tends to c. You may also go and simplify this 25, can write here 5 square, square minus 5 square, it means this is a square minus b square formula. So you may also write this simplification, x minus 5, x plus 5 also you can write, no, a plus b and a minus b formula. Okay, then divide by x plus 5. Okay, then these two results are get cancelled, only remaining this is the answer. Now you are applying this directly, c is equals to fill up, it means c minus 5, you get the limit answer. Okay, so you get the limit of x tends to c, f of x answer is c minus 5. Similarly we also check out the function, f of x is equals to directly I am going to fill up here. F of c is equals to c square minus 25 divided by c plus 5. Again I am going to take the simplification here also, same thing, c plus 5 c minus 5 divided by c plus 5. These two are get cancelled, remaining answer is c minus 5. Therefore the limit answer and function answer both are same. Limit of x tends to 5, limit of x tends to c, f of x is equals to f of c. The given function is continuous at every real number except minus 5. Now it is clear. So next example, last one is f of x is equals to modulus of x minus 5 is there. So in this case, observe it here. Whenever you get the modulus function, it means, I think I'm just remind that what is the f of x of modulus function, you have to split wise you write, it means what is the answer, minus x if x is less than 0, correct, then plus x if x is greater than or equals to 0. This is the condition. Okay, now the question is what, f of x is equals to x minus 5 they are given here. X minus 5 they are given, it means you have to write this result, f of x is equals to modulus of x minus 5, correct. Okay, so in this case again you have to write it split wise, it means this result is f of x is equals to here x minus 5, x in the place x minus 5 is there, no, so minus sign is there, first write it minus and then you write here x minus 5 if x is here 5 is there, no, so you have to take it here less than 5, you have to take it 4, it means 4 you have to write it here. Okay, so whatever number minus after that, it means you take it here. Suppose this is the plus 5, it means on that time you take here minus 5. All of you getting clear this point? Okay, and next here you take it, what is the only x in the place, x minus 5 if x is greater than or equals to 5 you have to take out. So next I will again come to this place. Now you have to prove this result. Again what is the question? You have to check the continuity only is there here. So in this case you are checking all the every real number, but whenever they up to in previous example what you are doing, just x is equals to c you are taking. Whenever they given here split wise, it means at that point you check out it is a continuous, it means in all the case it is continuous only. Okay, when you have to use this condition, all of you remember whenever they given here split wise LHL and RHL both are given, it means at that point you have to check it, it means it is sufficient to check out the continuity. So that's why I'm going to take it here x is equals to 5 in this case. Then what is the answer? First I am going to take here LHL limit. So in LHL limit, limit of x tends to 5 minus f of x. See this is x 5 minus, it means this is not the negative, this meaning is what, left hand side near value. Okay, now you have to fill up this result, limit of x tends to minus 5, okay. Limit of x tends to 5 minus, what is the f of x result in LHL side? LHL side is minus of x minus 5 is there, then minus you multiplied, what is the result, check out, limit of x tends to 5 minus x minus plus 5, then you apply this result, minus 5 plus 5 you get the result is 0. So this is your LHL limit. Okay, after getting LHL limit then you have to check out the RHL limit. Okay, in RHL limit of x tends to 5 plus f of x plus nothing but left right hand side near value. Okay, so next limit of x tends to 5 plus, what is the RHL limit? X minus 5, apply here x minus 5. Now you have to fill up this 5 minus 5 you get the result is 0. LHL limit is 0, RHL limit is 0. Okay, LHL equals to RHL you get. And what is the next result? Function also you have to check out, no, the function of f of 5. F of 5 it means at x is equals to 5, here only there is equals to symbol. Again what is the result here? X minus 5 is there. Now you have to fill up this 5 minus 5, it means you get the answer is again 0 is the answer. Okay, function answer and limit answer also getting same, it means, and what is the conclusion? The given function is LHL is equals to RHL is equals to f of 5 is equals to 0 is the answer. Therefore the given function is continuous at every real number. Now it is clear. Okay, next example observe here, question number 4. Prove that the function f of x is equals to x raised to n is continuous at x is equals to n, where n is a positive integer. Now observe here, f of x is equals to what they given here, x raised to n. Is it continuous function at x is equals to n, you have to take it here. N nothing but all the positive integer. Okay, x is equals to n only you have to take it. Okay, x is equals to n you take it means what is the limit answer? Limit of x tends to n f of x. Then limit of x raised to n f of x is what? X raised to n is there. Then applying n here, it means n raised to n. This is the limit answer. Then also you go and check out the function answer. F of n is also equals to n raised to n. Both answers are same. Both answers are same. It means the given function is a continuous at x is equals to n. Observe here next question. Is the function f is defined by f of x is equals to x if x is less than or equals to 1, 5 if x is greater than 1, correct? Okay, again continuous at x is equals to 0 question mark. It means you have to check out this if the given function is continuous at x is equals to 0 or x is equals to 1 and x is equals to 2. What is the given here? F of x is equals to x if x is less than or equals to 1, 5 if x is greater than or equals to 1. So in this case now you have to go and check out first x is equals to 0. X is equals to 0, it is continuous or not, you have to check out. See, so where is this point will be exist? X is less than 0, it means here only that result. X is less than 1, it means so this is the point answer, correct? So in this case we may also apply LHS limit or RHS limit, both will be exist in here only. Okay, suppose you go and draw this result, here is the 1 pointer and here is a 0. So x is less than 1, it means here only it will be exist. So both the results are here less than and greater than, both are existing in this side only, no? So it means you would simply take it here limit answer, one time you have to apply this result. Limit of x tends to 0 f of x. Limit of x tends to 0 f of x is what is the answer? X only. Now you have to apply this result, 0 is the answer. Okay, and also you check out the f of x is equals to 0, you have to check out, it means 0 answer is what, again function is x only. So f of x is equals to x, then f of 0 answer is also 0, then limit answer and function answer both are same. So limit of x tends to 0 f of x is equals to f of 0, therefore the given function is continuous at x is equals to 0. Okay, and next the second case, observe here. In the second question, what they given here, x is equals to 1, you have to check out. Is it a continuous or not? See, when you take out x is equals to 1, it means in this case carefully observe, 1 you take it means the given here less than condition and greater than condition, both the two results. So in this time you have to check out particularly LHS limit and RHS limit. Okay, so now I am going to check it here. LHS is equals to first limit of x tends to 1 minus f of x. So what is the LHS limit condition? Left hand side what they given here, observe x is there, so write it x. Then applying here 1, then what is the answer? 1 is the answer. Okay, left hand limit you get the answer is 1. Similarly, we also find out the right hand limit. Right hand limit you go and check out limit of x tends to 1 f of x, here plus sign because right hand side is there. Then limit of x tends to 1 plus, what is the right hand side answer? 5 is there, no, this is the constant function. So write it here 5 only. Greater than result, it is the RHS result always. So answer is given here 5. So write it here 5. Okay. Then you go and simplify this constant function limit you apply, it means so 5 is the answer only. Okay. So in this case observe LHS limit answer you get 1, RHS limit answer you get 5. These two are equal? No. So these two are not equal. It means what is the conclusion? In this case LHS is not equals to RHS. Therefore the given function is discontinuous. Okay, at the point x is equals to 1. Okay, so write it here, the given function is discontinuous at x is equals to 1, correct? One more question is that x is equals to 2. Okay, x is equals to 2 you have to take out where it is exist. First you observe x is greater than 1, here only it is, no? So x is greater than 1, it means here is the 1, greater than result, these all the result, here is the 2, it means in this case LHS and RHS both are exist in the this side only, no? It means only one time you take it here, limit answer this result. Okay, so limit of you are applying, it means limit of x tends to 2 f of x is equals to limit of x tends to 2, what is the f of x answer? 5, only one result is there here, correct? So 5 you get, limit of constant answer is 5 only. Okay, and also you check out f of 2 function x is equals to 2, you take it, means x is equals to 2. Here observe, here 1, here 2 is equals to also existing in this side only, greater than result only, it 5 is the answer only, no? Okay, so this result also getting here 5, limit answer also getting here 5, it means limit of x tends to 2, f of x is equals to f of 2, both are the equal answer and exist also, therefore the function is continuous at x is equals to 2. Okay, or all this function you observe, it means the given function is continuous at x is equals to 0 and at x is equals to 2. These 2 points it is continuous, but x is equals to 1 is discontinuous. Okay, next examples observe here. Find all the points of discontinuity of the f where f is defined by. Okay, here question number 6 to 12 we have to find out all the questions point the discontinuity of the point f. Okay, observe here the sixth one question. See, in this case also you have to check out that a continuous function, it means in this case already I will inform that whenever the given splitwise, it means you have to focus on this point only. Okay, that point is also you have to check out that these 3 ways. What are the 3 ways? X is less than 2 and x is greater than 2 and x is equals to 2. These 3 points you have to check out. Correct? Why you check it? These 3 points. Less than it means this is the LHL condition, greater than 2 it means it is the RHL condition, x is equals to 2 it means this is the function result. Okay, so now I am going to start this LHL result. LHL result f of limit of x tends to 2 minus f of x. Limit of x tends to 2 minus, what is the f of x answer? X is less than 2. Here is the result. So now I have to write it here. What is the result? 2x plus 3. Then applying this 2 only. So 2 you have to apply, it means what is this answer? 2 into 2 plus 3. So 2 into 2 is 4, 4 plus 3 it means 7 you get here. After getting LHS, the next result is RHL. Okay, in RHL limit of x tends to 2 plus f of x. Limit of x tends to 2 plus, what is f of x here? Greater than result. What is the answer? 2x minus 3 is there. 2x minus 3. Then you are applying this 2, it means what is the result? Check out here. Limit. Now I am going to applying this limit 2 into 2 minus 3. Okay, so 2 into 2 is 4, 4 minus 3 it means you get the answer is 1. Correct? Okay, so now here observe the LHL limit is 7, RHL limit you get 1, it means these two are equal? No. So it means LHL is not equals to RHL, therefore the given function is discontinuous at x is equals to 2 only. Okay, next example observe here, 7th one. So in this case observe here, first you focus on this points only. In this points minus 3 also there and a 3 also there. Okay, so here it means always you have to remember, you have to check out the result. First what is what? 3 minus 3 only. X is minus 3 you take, it means you may also check out this result. X is less than minus 3 and x is greater than minus 3. These 3 points are also requirement. X is equals to minus 3, x is less than minus 3, x is greater than minus 3. Is equals to it means that is the function result, less than it means that is LHL, greater than it means RHL condition. Okay, these 3 points are there, no? Here is equals to also there, less than also there, and here greater than. This result is observed, minus 3 is less than x, it means it is actually x is greater than minus 3, both are same only. Okay, so now here observe. So now you have to check out these 3 points, and also you have to observe here one more point also there, that is 3 result. Okay, so that point also have to check out. In this case x is equals to 3 also there, and x is greater than 3 also there, and x is less than 3 also there. Here x is less than also there, greater than also there, equals to symbol. It means now you have to check out x is minus 3, that point it is a continuous or not, and x is equals to 3. These 2 points you have to check out this. Okay, so now first I am going to take it here, x is equals to minus 3. Okay, x is equals to minus 3. First I am going to take it LHL condition. So in this LHL condition, what is the limit answer? Limit of tends to minus 3 of minus f of x, because you are taking x here, x is equals to minus 3. Next, limit of x tends to minus 3 of minus. What is the left hand limit of minus 3? Here is the left hand limit, x is less than minus 3 is there. So x is less than minus 3, this is your function. So write out here, what is the result of modulus of x plus 3. Okay, now minus 3 how to fill up here, it means modulus of minus 3 plus 3. Modulus of minus 3 means 3 is the answer. So 3 plus 3, answer you get 6. Now you get the answer is 6. This is your LHL answer. Then similarly, you may also check out the RHL limit. In RHL, you take it limit of x tends to 3 plus minus 3. This is minus 3 you are taking. So minus 3 plus f of x. Limit of x tends to minus 3 plus. Okay. RHL limit you have to take out. It means in this case you observe here minus 3 is less than x is given here. Minus 3 is less than x. It means x is bigger compared to minus 3. It means this is the meaning is x is greater than minus 3. Both are same. So now you get x is greater than minus 3. It means what is the function answer? Minus 2. So take out that result. What is the result here? Minus 2x. Now applying this result, what is the answer? Minus 2, x is equals to minus 3, minus minus plus 3 into 2 it means 6. Okay, LHL answer is 6, RHL answer also 6. Then we need to find out the is equals to result. Is equals to result also check out f of minus 3 is equals to, okay, what is the minus 3 is equals to answer? Is equals to symbol is here, correct? Is equals to is there, no? So is equals to on that time this is your function answer. Take out this. What is the result? Modulus of x is equals to minus 3 and plus 3. Here x in the place I am filling here minus 3. Okay. So modulus of minus 3 is plus 3 only. 3 plus 3 again you get the answer 6. Correct. So correct. Okay. Now here observe the LHL limit is 6, RHL limit also 6 and function answer also 6. All three results are equal. It means the given function is continuous at every point, or the given function is continuous at x is equals to minus 3, and then you go to the x is equals to 3 result. Okay. So x is equals to 3 you take it means again here also same condition. First thing is LHL limit. Okay. So in LHL you take out it means what is the result first? Limit of x tends to 3 minus f of x. Okay, here observe here two results are there, no, that's why I am taking here plus 3 here. Minus 3 result is over, it is continuous. Now I am taking here plus result, limit of x tends to 3 minus, what is the left hand limit result? Lesser result. So lesser result you have to observe, it means in this case here observe. There is an x is less than minus 3, x is less than minus 3, this is function you have to take it here. What is the result? Minus 2x. Then 3 you have to fill up here, 2 into 3 it means minus 6 you are getting answer. Correct. Next case RHL you also have to check out. RHL. In RHL it means you take it here limit of x tends to 3 plus f of x. Limit of x tends to 3 plus, what is the f of x? Greater than x, 3 you have to take it. X is greater than 3 it means here is the result. X is greater than 3 it means here function. What is the result? 6x plus 2. Now 3 you have to apply here. What is the answer? Check out. 6 into 3 plus 2. 6 into 3 it means what is the answer? 18. 18 plus 2 it means what is the answer? 20. So LHL is not equals to RHL. So it means you write it here, LHL is not equals to RHL. Therefore the given function is discontinuous at x is equals to 3. In this case you have to write out here x is equals to minus 3 is a continuous, but x is equals to plus 3 you take it means that is a discontinuous. The given function, what is the discontinuous point? It means plus 3. The given function is discontinuous at x is equals to 3 only. Okay. Observe here 8th question. What is given here? F of x is equals to modulus of x divided by x if x is not equals to 0, and then 0 if x is equals to 0. Okay. Now observe in this case, when you are observing this result, this complete function, it means this is actually signum function. Okay, in first year already you studied. In signum function again it is a minus 1, 0, 1 are there, no. Okay, here observe in this case, here modulus are there, no. So modulus it means again what is the result? If x is less than 0 then result is minus x. If x is greater than 0 plus x you are taking. Okay, now you have to go and write it in this manner, result. If in this case I am going to take it here modulus is there, no, so I am going to write this result, x is less than 0 I am taking me, you take it here, this modulus result is minus x. Okay, minus x divided by x, x as it is, but here only that is a minus x. So these two x cancel, what you get answer? Minus 1 only. Okay, when it is if x is less than 0 you get the minus 1. And same case I am going to take it here, if x is greater than 0 I am going to take it mean what is the result? In modulus function you take it here x only. Okay, denominator already x is there, so x cancel. What you get here answer 1 when f x is greater than 0. Here x is equals to 0 already they given, no. If x is equals to 0, what is the answer? 0 is the answer. Okay, finally what are the getting answers? Observe here, your function f of x is equals to minus 1 if x is less than 0. If x is equals to 0, what is the answer? 0. 1 if x is greater than 0. This is your signum function. Okay, so both the results are same only. Okay, now you have to check out this less than 0, equals to 0, greater than already there. It means you need to check out at x is equals to 0, this point it is continuous or not. Okay, first case I am going to take it here, LHL. Okay, in LHL what is the result? First limit of x tends to 0 minus so 0 minus f of x. So what is the result of left hand limit in x is less than 0? It means this is the result of minus 1. So write it here minus 1. So minus 1 you fill up, it means limit after applying constant function, it means you are applying limit, it means that minus 1 constant function answer is only you are getting. So LHL limit you get minus 1. Similarly you may also find out RHL condition. Okay, so in RHL you go and check out limit of x tends to 0 plus f of x. Limit of x tends to 0 plus, what is the plus result? It is greater than 0. What is the answer? 1. So write it here 1, and this answer you get plus 1. RHL and LHL both are equal? No, these two are not equal. LHL is not equals to RHL. Correct? So these two are not equal, therefore the given function is discontinuous at x is equals to 0. Okay, last you write on the conclusion, the given function is discontinuous at x is equals to 0. Okay, this is your last conclusion. So ninth question, observe here, this is also same type, again it is a changes here in this place. If x divided by modulus of x is there, and here x is less than 0, minus 1 if x is greater than or equals to 0. Okay, this function also you have to write it in this format. If x is less than 0, it means less than 0, what are the value? Negative values only. Okay, when you take it negative value, it means what is the modulus condition? Minus x only. So in this case you write here x divided by minus x. Here this x as it is you write it, but in this modulus only I am discussing here. Modulus function already you know that, no? Minus x if x is less than 0, plus x if x is greater than 0. Here only discussing minus, because less than results and that time minus x. So then these two are get cancelled. What is remaining here? Minus 1 is remaining when it is if x is less than 0. Correct? And greater than 0 already given here, minus 1 if x is greater than or equals to 0. So now here in this format you write it, now it is very simple to find out the next cases. What is the final? You get the answer, f of x is equals to minus 1 if x is less than 0, minus 1 if x is greater than 0. Okay, now you have to go and check out LHL and RHL. Both answers are minus 1 only, no? Function answer also getting same only. Okay, you may also check out that result, a limit of first you take it LHL result. LHL result x is tends to 0 minus f of x. Then the limit of x tends to 0 minus x. What is the answer? Less than condition minus 1. This answer also getting minus 1. Then RHL also you have to go and check out limit of x tends to 0 plus f of x is equals to limit of x tends to 0 plus, what is the RHL condition? Greater than result. Again it is a minus 1. So write this result minus 1, and function also you take out, it means z equals to 0. Here is a is equals to, what is the answer? Again it is a minus 1. It is a constant function is there. It means all the results are same. What are the result? LHL result, RHL result and function answer. So both the results are same. It means you write here limit of x tends to 0, f of x is equals to f of 0. Therefore the given function is a continuous function. Okay, here you have to write it, the given function is continuous at every point. Okay, so in this example there is no discontinuous points. It means all the points it is a continuous only. So write the conclusion, the given function is continuous at all the real numbers. Okay. Next example, observe question number 10. F of x is equals to x plus 1 if x is greater than or equals to 1, less than or equals to 1, it means again what is the result, x square plus 1. Again it is a simple case, you have to check out at the point x is equals to 1 point. Okay, now what is the procedure? First you take out a LHL limit. Okay, now you have to take out the LHL limit. Limit of x tends to 1 minus f of x is equals to limit of x tends to 1 minus what is the lesser condition, carefully observe, this is your lesser condition. Now they are given here downside. Okay, always it is not in getting upper side. Here also observe the split by the second result, x is less than 1, it means what is the answer, x square plus 1, write it here, x square plus 1. Now you have to apply this result, 1, now 1 square is 1, now 1 plus 1 is 2 you get. Okay, so LHL limit you get the answer is 2. Similarly you may also find out the RHL. In RHL what is the result, limit of x tends to 1 plus f of x is equals to limit of x tends to 1 plus what is the RHL result, here is the greater than condition, answer x plus 1 is there, write it x plus 1. Okay. Now you have to apply 1 plus 1, it means you get the answer is 2. So LHL limit and RHL limit both answers are same, and last result function f of x is equals to, where is f of x is equals to, here is the result. So now I have to write it here, x plus 1, then applying x is equals to 1, it means 1 plus 1, that result also getting 2. LHL equals to RHL, also limit answer is also equals to function, therefore last you write here limit of x tends to 1 f of x is equals to f of 1, therefore the given function is continuous at every point or every real number. In this example also there is no discontinuous points. Question is find the discontinuous, no? So write the conclusion, there is no discontinuous points. Okay, today I am going to complete it totally 10 example. In the next video I am going to continue next questions.